Isn't that the question?
Yeah, yeah, but the
Or
in the first
I
one,
just
I
need to
just
count
want,
all the
yeah, because the first one I want the total number of pixels that contain edges, because I want to
Okay.
the edges.
So it's then it's
Of course, in the test,
19 divided by 25.
yes, 19. So this is total.
Yes.
So in this case, I would ask more precisely in the test. So first, the edginess, you have 19 divided by 25. Regarding the strong edginess and weak edginess, okay, what do you want to say about that?
So I would say that we have 11 strong edges and
Okay.
8 weak ones.
Concerning the, let's say, the orientation, horizontal, vertical, and diagonal.
Right. So we have 4 horizontal edges, uh, 4, 7 vertical ones, and 8 diagonal edges. So 4 divided by 25, 7
Yes.
divided by 25,
Good.
and 8 divided by.
Good. Yep.
I think that's it. Yes.
E o João Porto? João Porto, atira-te aí ao 19. Could you please share your screen? Could you be so kind to share your screen with us and then try to
I've
solve
been
it?
focused on the project itself and not studying it, so
Opa,
for sure.
tá bem, tá bem. Então, o Diogo Pinto,
19.
sim, please.
Okay. Just a second. So, oh, intersection. Oh, okay. 19. Okay. So,
I think it's better to share your screen.
yeah, I'll share it. I'm not really sure about this one.
So first, the intersection is just to compute
Yeah,
the minimum.
I can. I did it. But I can show you. How I did it. So.
Ai, tu já fizeste.
Yeah.
Ai, não querias partilhar.
So I don't. I want to write in here. So yeah, okay. So I'm not sure, but what I did was compared both of these, and then I selected in each one which one was the
minimum.
Yeah, and then I added them all up. So
okay. No, yes. So this should be something like 4 plus.
And it was. I have it on paper, but it was 15.
Ah, ok. Então isto vai dar 4 mais 3
I'm not
plus
mistaken.
1 plus 4 plus 2 plus 1. Yes, it's 15. Yeah, 15.
And this one, I'm not. And then the second one, I was not really sure, but
because the match, I want to.
I think it was the same thing. It was like the same as this one. I would choose the same values, but then I would choose the. I would divide them by the values on the H2 on the second. Yeah.
Yes. But again, in the quiz, I should mention what is the histogram that stands for the model, because I want to specify the model, because you cannot guess. So in this case, you can assume that the second histogram is the model. So you divide it by the bins of the second model.
So it was.
Não é 15,
Uh,
é 15 a dividir por.
oh, it's 15 by.
No.
Okay.
The match, the second operation match is 15 divided by 4 plus 3 plus 1.
Oh, okay.
4
Okay.
plus 1.
Okay. I did it like this.
Divided by
Okay.
16.
So. Yeah. So it's. Okay. So it's.
Yes, so yeah.
By 16 by the second one. Okay.
Okay, good.
Okay, so now that I'm here, I have a doubt. I mean, I don't really know how to do this one.
Ah, que engraçado. Okay, so let me CDF. Okay, so wants to help. Sorry, what's your name?
Okay.
Sorry,
Diogo.
Diogo.
My name is
Wants to help Diogo. Patricia, are you available?
I mean, I'm available, but I don't know the answer.
Ah, you don't know the answer. Good.
I can do it.
Okay, let me see. What is the question? This is a
It's
cumulative
12.
distribution function, I guess. Onde é que está isto? Ah, caraças. Ah, ok. Okay. So
So,
first.
I can stop sharing.
No. You
Okay.
can.
Okay. So. Okay. I'll
Want
share.
to
Okay.
solve this here?
I can solve it if you want.
Okay, please do.
Okay, so we just have to count the number of occurrences of each
Yes.
number.
Yeah. Okay.
Okay, so please write down there.
So in this column.
Yeah. So we go 1.
3, 1, 2. Okay.
Portanto, deixa-me cá ver isto. 3, 4.
3, I guess. Two. Oh no. Okay. No. That's not right. There are 2 6s. 7. 1. I mean 1 is 1 7. 4.
Pequena válvula, 2. Qualquer coisa aí que está mal. Sei lá, o 1 quantas vezes ocorre? Occurrence of 1 is 1. Occurrence of 3 is 1. So it's okay, it's 2. Occurrence of 4 is 1, 2. Não, está qualquer coisa está mal aqui. Tu tens duas ocorrências de 3, não é? Não, tens o CDF, the CDF of 3 is 2.
Yeah.
And then you pass to 3, why?
No, it's
4. It's 3 times.
There's 4. There's 3 4s. 1 2.
Okay.
Then 2 6s, I think.
Okay, so you count. Okay.
Yeah, 1 7 and 4 8. Where's the 4 8? Yeah. 1 9 and then.
Okay, this was supposed to be the cumulative, so we're supposed to do like so.
Okay, so let me share the screen again. Sorry.
Okay.
This is not good.
Okay, I see what it is.
So first, and recall chapter. I don't know. This is chapter 4. The first thing is that you have the value, and then you have the count. Okay. So in the first column, you put the values of the matrix. So you just pick up these values here, and count the occurrence for each of the intensities. Value count, and so on and so forth. For instance, 154, it occurs one single time. Okay. Then after the count, you are in conditions to compute the cumulative distribution function. So for instance, so you just range from the minimum to the maximum value intensity in the matrix, and then you have this count. So this means that the intensity 52 occurs one time, the intensity 55 occurs 3 times, and so on and so forth. Then you're going to compute the cumulative distribution function. So in this case, 52 is 1. And then if you have 3, you just compute the summation between 3 and 1. You have 4. And then you have 2 occurrences for 58. So you compute 2 plus 4, and you have 6, and so on and so forth. So this is the one. So before your calculation of CDF, you must count the occurrences for each of the intensities. So in this case, in this exercise, I want to compute the CDF here, okay? And finally, after the CDF, I'm in conditions to compute the equalized intensity, okay? And this, let's say, you use this formula here. You can consult the formula during the test, I don't care. So basically, during the, let me see, Alt F. Eu hoje não sou capaz de escrever nada aqui. So in this case, you have, I think you should help me on this. So 1, 3, 4, 5, 6, 7, 8, 9, 10, 12, 14, and 16. So how many times? So do you have this here? How many times 1 occurs? So 1, is that so?
1,
3, 1.
3,
No,
2, 2,
2, 2,
4,
3,
3,
5,
2,
6,
2,
see, 7,
1,
1,
8,
4,
4, 4, 9,
1,
1,
10,
3,
3. Yeah, 3.
12, 2, 3,
3,
14,
1,
1.
and finally 16, 1.
1.
Okay, so computing the cumulative distribution function, you have 1, 3, 6, 8, 10, 11, 15, 16, 19, 22, 23, and 24. So this is cumulative distribution function. So this is precisely that I want to fill here in the second column. Finally, for the third column, it's simple. So you have this expression here, okay? For instance, what is CDF of 8? no, sorry. So, yeah, this is sorry. This is the value v. This is counting the value, and I want to figure out what is the equalized histogram for these values. Remark one thing, that you have the initial image, and the initial image is a matrix that contains these values. So I want to compute the histogram equalization from these values that I mark here in red. Okay, so for instance, computing the histogram of 5, it is the CDF of 5. What is the CDF of 5? It's 8 minus, what is the minimum CDF? Is 1 divided by m times n. In this case, this is the size of the matrix. Let me see what we have here. So you have 1, 2, 3, 4, 4, 1, 2, 3, 4, 5, 6, 24. So you have 24 4 lines times 6 columns minus 1. And if you have a gray value, if this image, again, I had, if I put this question in the quiz, I have to specify the range intensities of the image. So in this case, assuming that the image is gray, you have 235 levels, or in this case, it depends on the question. I can assume that you have 16 possible values, so this can be also 16. It depends on the question. Minus 1. Okay, and that's it. And then you repeat for any other values in the matrix. Okay, you repeat the calculation again. If I ask for this in the quiz, the matrix should be very, very small, because this you have to compute 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 calculations. This is not nice. Okay, this is just for you to train. But I can ask this the same exercise, for instance. But for instance, for a matrix 2 by 2, and then you had just 4 calculations, not this, because this is very boring to, and I think it's a little bit demanding to put this exercise in the quiz. Okay. So, but this is the reasoning behind. Okay. What about this here? This is in Portuguese, but I just want to refer what is the kind of cases that you have in the bounding boxes, that whenever you are detecting objects in the image. Some groups already show me some interesting phenomena that they obtain when they are trying to, the second word, One possible thing is whenever you have an object and you have a bounding box surrounding its silhouette. So this is called correct detection. Correct detection. Another situation is whenever you have a pedestrian, for instance, or even a car, and you have something like, and for instance this here, so two bounding boxes to represent the pedestrian. And perhaps I'm pretty sure that you already come with this in the second work. Okay, so this is split. Also, you can have this sort of split here. So whenever you have two bounding boxes to represent, let's say, the object. And so one situation, two situations, and there is another one. Indeed, there are more, where you have several pedestrians and you have a bounding box to represent, let's say, these two objects. So in this case, we have a third situation that is called merge. Also, it is possible, so I just want 2, 3, but there are more. There is some cases whenever you have this here. So you have a pedestrian, another pedestrian, you have this merge, and here. So here it's possible to have a split merge. Okay, whenever there are situations that occur at the same time. And there are two more. Okay, let me erase this here. Suppose that you want to perform a tracking of pedestrians and cars, and you see a fluttering stage in the window. Like here, for instance. I know this sequence very well, and in this case, there are a window that is reflecting here, and sometimes even when you do not want, you have some objects like a pedestrian, another pedestrian. You detect them correctly, and then you also have another bounding box located in the window. This is false positive, or false alarm if you want. False positive. And finally, you also have the so-called ghost. Okay, what is a ghost? is whenever you detect a region and the object disappears. Suppose that you have an image and you have, let's say, a car that is parked. And this is the background image. Okay? So you have several trees, you have a road, you have a building, but then you have a car here. Okay? And this is your background image. So you estimate your background model and it contains static objects. And then you start to apply your foreground algorithm for detecting objects. And you have a bad luck. And at some point, the car starts to move. So you have a building. Ops, oh caraças. Oh, e o que é que se passa aqui agora, caraças? Oh, que coisa. Eu tenho que reinstalar isto. You have a tree. You have a road. And the car starts to move and leaves the scene. So in this case, when computing the difference between the background and the current image, you will detect an active region. A region that represents an empty object. This is called a ghost. So you have 6 possibilities. I just asked for 3. Remark the chapter, I guess 6 that you, yes, chapter 6 that I mentioned several situations that occur in surveillance systems whenever you want to detect regions in the video sequence. Okay. So these are very simple cases, and I think you can understand them well by using draws and some illustrations. And yeah, that's it. I just wonder to ask João Porto if during the execution of the second work you already faced some of these situations when detecting pedestrians and cars and whatever. If you already faced some, let's say, some splits or merges.
I'm still tuning the algorithm, but yeah, sometimes there's false positives. Yeah. Also, the ground truth is not really true sometimes, because there's people who should be detected that are not in the ground truth detection boxes. Like in the S2L1 dataset, I think that's the one we're supposed to use.
Do you mean some region, some bounding boxes in the ground truth that represent the objects that are not there?
Yeah, so people are not being detected. There's a path in the top left corner where there's people sometimes walking by and there's no boxes detecting them.
Okay, let me discuss that with you in a few minutes in the project laboratory. Okay, in the laboratory.
Okay, all right.
Okay, because I guess let me share again the screen. The second work. What is second work? Yeah, because there are 2 versions of the ground truth, I guess. Let me see what can I. Let me try to fetch. Comunicação resolutiva. Onde é que estão as práticas? Ok. Okay, let me share the screen. Tanta coisa aberta aqui, meu Deus. So I guess you managed to yeah, complete. What is complete? Complete. I guess complete, it contains all the detecting, all the bounding boxes, even when the object is not present. In cropped, I guess it's only the objects that are detected. Let me... Por que é que isto não dá? Ah, ok. Deixa-me cá ver. João, did you manage to work with this this second file, cropped?
I'm pretty sure I'm using complete, and there's missing boxes there, but I could be wrong, and maybe I got the cropped version.
Okay. So I think the complete data set for each data set. Yes, it's here. For each data set, there are two ground truth files. One, complete, contains annotations for all visible targets. The other, cropped, only contains target within the predefined tracking area used in our experiments. Complete contains annotations for all visible. No, I think you should use complete, because the annotations refer to the visible targets. But we can discuss that. The other work cropped only, please. The other work is cropped only. Targets within the predefined tracking area. Okay. So I think we are in conditions to finalize this lesson. We have more 10 minutes, but again, try to study a little bit. The things that I mentioned here I may put some questions regarding this, the stuff that I've shown here today with you. But don't forget, try to read slides and try to think about it, and try to make a couple of exercises. Okay. So if you are okay, we could finalize this lesson, and at 3:30 we can gather again and to discuss some issues regarding the second work. Do you agree?
Sure.
Okay. So thank you so much, and I expect to see you in 1 hour and a half, more or less. Okay. Thank you.
Goodbye.
Okay. Goodbye.